Okay, these are the section 5.5 notes. You should have your textbook open to page, 310. We're going to start talking about inequalities that have absolute values in them. And we know that an absolute value is a number's distance from zero. So when we talk about an inequality that has that in there, it's really similar to an inequality an absolute value equation. We just have a few numbers to add in there. So when they say the absolute value of x is smaller than 3, we know the absolute value is the distance from 0. All that's saying is the distance between x and 0 is smaller than 3. Now there are two numbers where that's true. -3 and all the numbers bigger than that, and then +3 and all the numbers smaller than that. So we know that the absolute value of 2 is smaller than 3. So when we write that in set builder notation, we write it as x such that -3 is smaller than x, which is smaller than 3. This will make more sense as we do some of the actual examples once we turn the page. To graph it, we'll have to start with -3 and go all the way up to +3. We have an open circle at -3. X is bigger than that number, so it's going to go to the right. And then we have an open circle at +3, and x is smaller than that number, so it goes to the left, so it connects, okay? When we solve an absolute value inequality, we have to consider two cases. And that's what we have up here. Do you see how we have a case here and a case here? So kind of something to follow up for all of these questions is you have to have case 1, where the expression inside of the absolute value symbol is non-negative. And the reason we say that non-negative instead of positive is because that can also include 0. So when we say non-negative, it means all the positive ones and or 0. 0 is neither negative nor positive, that's why we have to say non-negative instead of positive. Case 2, the expression inside of the absolute value symbols is negative. Because up here, we have a negative answer and a positive answer. So we could say instead of positive, non-negative. So the solution is the union of solutions of these two cases. So we had two cases, we smushed them together, and we got our union. Turn the page. So we have an example. We have to consider both cases. One where this is positive or non-negative, and one where this is negative. So we're going to say non-negative for case 1 and negative for case 2. Now, instead of trying to change all of these things to positive and negative, we just change what's on the right-hand side. So over here, it says non-negative. 11 is already there, so you just leave it alone. We say m plus 2 is less than 11. To solve that, we subtract 2 from both sides, and I get m is less than 9. Okay, for my negative case, I'm going to take m plus 2, and I believe we have to flip the sign. I want you to look on page 310. Do you see how this is the exact one from example 1? And case 2, do you see they leave the sign the same? So we're going to say negative m plus 2, remember we said what was inside the absolute values is now negative, is less than 11. Now in order to get rid of this negative out front, I'm going to make it a -1. It's being multiplied, so I'm going to distribute. I have -1m minus 2 is less than 11. So in order to start solving this, I add 2 first. I get -1m is less than 13. I want to get m alone, so I'm going to divide each side by -1. And I get m is greater than -13. It becomes greater than because I multiplied by a negative number. So now I have my two solutions. I'm going to write them together so that we can see them all in one place. I'm going to have m is bigger than -13, but m is smaller than +9. So I have to go from -13 all the way up to +9. I ran out of room on my number line, so just add it in there. Okay? I'm going to have an open circle at negative 13, and m is bigger than negative 13, so it goes to the right. But m is smaller than 9, so open circle and to the left, and they connect. All right, I want you to try this next example on your own and then stop. I'm going to keep going, so you should pause the video. Okay, so I have the absolute value of y minus 1 is less than negative 2. So I'm going to start by making case 1, which we said before was our non-negative case. And that makes y minus 1 less than negative 2. This stays the same because it stays our positive values on the inside of the absolute value. So I'm going to add 1 to both sides. Y is less than negative 1. And I'm done over there. Then I'm going to make case 2, which we decided was our negative case. So I'm going to take the insides, which is y minus 1, and I'm going to put a negative 1 out front, just like I did up here to make it my negative case. I leave the symbol the same, less than negative 2. Distribute the negative 1. I get negative 1y plus 1 is less than negative 2. Subtract 1 from both sides. Negative 1y is less than negative 3. Divide each side by negative 1. Y is greater than positive 3. Switch the signs. So now I have y is bigger than 3, but y is less than negative 1. I'm going to draw on my number line here. I know I have to go from negative 1 all the way up to positive 3. And I have an open circle at 3. And it tells me that y is bigger than that number, so it goes to the right. And I have y is less than negative 1, open circle, and to the left. Now, remember on the first page, it told us that the solution is the union of the solutions of the two cases. We've been drawing in what look like headphones, which we learned in the last section is usually what an intersection graph looks like. But since this can happen to the very same thing, we can tell that it's actually a union because it can split apart. All right, turn to the next page. The inequality where the absolute value of x is greater than 3 means that the distance between x and 0 is greater than 3. So this is very similar to what we had on the front page. We just switched our sign around, so instead of less than 3, it's greater than 3. Same kind of thing where I have two answers in my solution, and when I go to graph it, I'm going to see something different happen, okay? So if I have negative 3 and 3, I know I have to go all the way from negative 3 to 3. I have an open circle at both because it's less than and greater than. Now, x is less than negative 3, so it goes to the left. Then it's greater than positive 3, so it goes to the right. Just like that last example. All right, so remember you have to consider both cases. Go ahead and do the next example on your own. You need to pause the video because I'm going to keep going and come back when you're ready. All right, case 1 is non-negative. So I get 3n plus 6 is greater than or equal to 12. Everything stays the same, I just drop my absolute values. Subtract 6, 3n is greater than or equal to 6, divide by 3, n is greater than or equal to 2. Now my case 2 is where I take in that negative, and I put negative 1 outside of what's on the inside of the absolute value. So I just put the absolute value stuff here, and then put negative 1 on the outside. That makes it our negative case. And I have greater than or equal to 12. Distribute your negative 1. Negative 3n minus 6 is greater than or equal to 12. Add 6. Negative 3n is greater than or equal to 18. Divide by negative 3. N is less than or equal to negative 6. That sign changes because I divide by a negative. So now I have my two solutions. It's bigger than or equal to 2, but it's smaller than or equal to negative 6. So I have to go all the way from negative 6 to positive 2. Okay, I went one past. I'm going to have a solid circle at both because it has that equal to symbol in there. Now it's bigger than 2, so it goes to the right, and smaller than negative 6, so it goes to the left. Okay, go ahead and turn the page. here is 2 more examples. I want you to try these ones on your own again. Pause the video and come back when you're ready. So I have case 1, which we know is our non-negative. So I leave it alone. 2k plus 1 is greater than 7. Subtract 1. 2k is greater than 6. Divide by 2. K is greater than 3. Alright, then I have case 2, which is our negative. So I take that 2k plus 1 and put a negative 1 on the outside of it, greater than 7. Distribute the negative 1. Negative 2k minus 1 is greater than 7. Add the 1. Negative 2k is greater than 8. Divide by a negative 2 gives me k is less than negative 4. So now I have my 2 solutions. K is greater than 3. K is less than negative 4. I know I have to go all the way from negative 4 to positive 3. Alright, I have open circles at both because they don't have the equal to symbol. It's bigger than 3, but smaller than negative 4. Okay, our next one is the absolute value of r minus 6 is greater than or equal to negative 5. Once again, I start with case 1, and I have r minus 6 is greater than or equal to negative 5. Add the 6. R is greater than or equal to 1. So then I have to start with my case 2, which is my negative case. Write what's on the inside of the absolute value and add that negative 1 to the outside. Greater than or equal to negative 5. Distribute. Negative 1r plus 6 is greater than or equal to negative 5. Subtract 6. Negative 1r greater than or equal to negative 11. Divide by negative 1. R is less than or equal to positive 11. So I have r is greater than or equal to 1 and r is smaller than or equal to 11. So I have to go all the way from 1 to positive 11. Okay, I have solid circles at both of them because they both contain the equal to symbol. R is bigger than 1, but it's smaller than 11, so these ones connect. Alright, turn to the next page. This is a word problem example. A recent survey showed that 65% of young adults watched online video clips. So that would be like YouTube. The margin of error was within 3% points. So they're saying that the survey was not exactly accurate. It's saying within 3 percentage points, it should have been accurate. So, find the range of young adults who use video sharing sites considering those errors, so that 3% error, and then graph the solution. Okay? So, we know that there's a certain number of them. That's what we're looking for. A certain X is going to be the number of young adults who watch videos. Okay? Now I know that the number of kids that are watching these videos is supposedly 65%, but they say that's give or take 3%. So it could be 62 or it could be 68, but they want us to give us an algebraic expression of that. So we're not sure how many of them actually watch them, because it also could be 64 or 64 and a half. We're not quite sure. So we're going to say that the number of them, subtracting the percentage that they tell us are watching them, they're saying within those percentages, we should only be off by 3. So it should be less than or equal to 3. Now the reason I'm using less than or equal to instead of just less than is because it uses the word within. And if you remember from our notes from section 5.4, between is less than or greater than, within is less than or equal to, greater than or equal to. So the number of kids that watch minus the number that they tell us watch should be smaller than 3. Now, remember that if x is like 64, when I subtract 65, I'm going to get a negative number, and I can take that absolute value. That's okay. because the absolute value of that would still be 1%, which means it's 1% off from that 65. Okay, so let's go ahead and solve. I have case 1, which is our non-negative, which means x minus 65 is less than or equal to 3. Add 65, add 65. X is less than or equal to 68, which we decided. If it's within 3 points, it should be 68 or smaller up to or down to 65. Okay, then I have case 2, which is my negative case. So I have a negative 1 out front, and then I have my x minus 65, less than or equal to 3. I'm going to distribute negative 1x plus 65, less than or equal to 3, subtract 65. Negative 1x is less than or equal to negative 62. Divide by a negative 1. X is greater than or equal to positive 62. Which we know 62 is as small as it gets, so it has to be everything bigger than that. Okay, so on our graph, we have our two solutions. We have x is bigger than or equal to 62. X is less than or equal to 68. So we're going to go from 62 to 68. Okay, I have solid circles at both because they have the equal to symbol. It's bigger than 62, but smaller than 68. So I get that graph. Turn to the next page. The melting point of ice is 0 degrees Celsius. During a chemistry experiment, Jill observes ice melting within, remember that within means that it has to have the equal to symbols underneath our greater than or less than, 2 degrees Celsius of this measurement. So when you go outside and the ice is melting, it doesn't necessarily means at a certain degree. It's not necessarily 0. It could be at -1, it could be at +1, it could be at -2 or +2, and that's what they're saying. So just like on that previous example, we're going to talk about the range of melting for Jill. So we're going to write the range of temperatures that Jill observes and then graph the solution set. So we know, let's say T is the temperature for melting ice. Okay? And I know that T minus 0, because that's the melting point, is going to be smaller than or equal to 2 degrees, because the temperature that's actually melting minus what it should be melting at, it has to be within those 2 degrees, so it has to be smaller than 2 degrees change. It can't be bigger than 2 degrees change. Okay? So now I have this, but I can simplify this. This is just saying the absolute value of T, because T minus 0 is just T, is less than or equal to 2. So let's consider our two cases now. I have case 1, which is my non-negative, where I just say T is less than or equal to 2. Nothing else to solve. Then I have case 2, which is my negative. Okay, I'm going to distribute that -1, so I get -1t less than or equal to 2, divide by -1. I get t is greater than or equal to -2. Which makes sense. If it's supposed to melt at 0 degrees, but sometimes it can melt within 2 degrees smaller or bigger, it can melt at -2 degrees or +2 degrees as well. So now I have my two solutions. I have t is greater than or equal to -2. T is smaller than or equal to +2. On my graph, I go from -2 to +2. Solid circles because it said within. And it's bigger than -2, but smaller than +2. So those are our graphs. This is the end of the notes. You need to remember to finish the 5-4 assigned problems, and we will do examples of the 5-5 homework tomorrow in class. If you have any questions about the notes, send me an email and I'll try to get back to you. Otherwise, I will see you on Thursday.